Okay, I'll go ahead and get going. Greetings, everyone. Welcome to our BRAINSTEM panel discussion on flood resilient Bangladesh. This is a series of events, and today's topic is dams, diversion, and rivers. This initiative has been led today's session by Professor Jassim Imran. So he is of University of South Carolina, and so as usual, we are recording this session. We have three distinguished speakers with us. And there will be during the time, the first, the half of this event, our distinguished speakers and Professor Imran are going to share their perspectives. And then during that time, all of us will be muted, and whatever the questions, because we encourage to have, and we have a tradition of having animated discussion. So please keep posting your questions in the chat box of Zoom. And if you are a little less familiar with Zoom, then depending on the device that you are using, so in the more section, you should see the chat if you're using a tablet. And from that perspective, I would just hand it over to Professor Imran, and Professor Imran will be taking over from here. Thank you so much.
Thank you, Professor Hussain, and thanks to the audience for joining this session. And I'm sure more people will trickle in. We have three distinguished speakers. Let me just share my PowerPoint so that I can introduce them and also a little bit of background information on this topic. All right. We have three speakers. Two have joined, and I'm hoping the third one can join as well. It's my great pleasure and honor to introduce the speakers to the audience. Professor Jim Best is a leading earth scientist. He has studied many of the Earth's largest rivers, and he has done groundbreaking work on the Padma-Jamuna river system. And he has a keen understanding of the river dynamics there. Professor Chaudhary is an expert hydraulic engineer. He has worked on dam projects worldwide, and he has led major research on flood modeling and dams and levee bridges. And Professor Parker, I hope he would still join us. He is the top expert in sediment transport and river mechanics. He is a member of the National Academy of Sciences. So people of Bangladesh are actually remarkably resilient to flooding. While fatalities remain relatively low, even during large floods, property and infrastructure losses are piling up, with each flood affecting a fragile economy and infrastructure. So the image you see here, I've taken it from a recently published news article, and it shows a couple returning to their flood shelter after checking their home. And despite the tremendous hardship they face, they do not appear stressed, and it reflects their incredibly resilient mindset. On a side note, not many of us would do the same that this person is doing. His wife is sitting on a banana float like a queen, and he's pulling the float, being in negative water. So kudos to this guy. So climate change is making floods more severe, and urbanization, industrialization, land grabs, and wetland losses have worsened the drainage situation. A single lost crop can financially cripple farmers, pushing the limit of their resilience. So flooding is not the only challenge that the people of Bangladesh face. The dry season is actually the growing season where the farmers grow most of their crop. So due to the construction of a barrage in Farakka, India, the Padma River or the Ganges River, most of the water is diverted to Calcutta port. As a result, there has been an increase in salinity in southwest part of Bangladesh, and also lack of irrigation water in these areas. So Bangladesh government has at different time done feasibility studies, and during the last decade, they did a feasibility study and proposed to build a barrage here. So I think right before kickoff, this project was scrapped, and according to the news reports, it was on the behest of India. Bangladesh also has built other barrages. There is one barrage in central north part of Bangladesh, and that barrage is on Tista River, which is a tributary to a major tributary to Brahmaputra River. And despite building a barrage, they cannot use it because the water is withdrawn upstream. I mean, Bangladesh can build a huge infrastructure like a barrage here, but what is the use if there is a lack of equitable water sharing? So Bangladesh first needs to have a long-term or permanent water treaty so that they get their water share, which is equitable and sustainable. And then those infrastructure might be useful. Otherwise, it might be a waste of money and and may cause long-term environmental and ecological damage without reaping any benefit. So in closing, I would invite our esteemed panelists to share their insights on dams, diversions, and river dynamics. So each panelist would present for about 10 minutes. And then after that, we can have a Q&A session where participants may ask questions and they would share their thoughts. So with that, I yield the podium to Professor Best. And if you can share your screen and make a presentation. I've stopped sharing mine.
Okay, thank you, Jassim. Yeah, sure. Hopefully you can see my screen now. Okay, many thanks, and many thanks for the invitation today. Actually, it's a real pleasure to be part of the group and speak to the group. We've been conducting quite a lot of work on sand mining in Bangladesh at the moment, but what I'm going to do is actually just talk about some aspects of some work that a group has conducted a few years ago that concerns scours and channel stability. And I'm going to mainly talk about this work that we were fortunate enough to conduct in Bangladesh, but I'm going to, if I get time, just talk about some work and some modeling work that we on the Amazon at the moment, which I think also may be pertinent to some of the discussions maybe that we'll have later. So that's what I'll try to do in 10 minutes. So the background for this is we've been very interested in large-scale scours in alluvial channels, both their location and their dimensions and size. I suppose, of course, the importance of this is that these deep scours set the depth of the basal erosion surface, which it has geological implications, but of course it's important for infrastructure. And so what a groupers have been doing, and I'm just one member of a group, and there's a range of people here who are involved in this project and this surveying a few years ago now, actually. What we were interested in doing is looking at the locations and dimensions and characteristics of scours across the transition from the zone up here near the Ganges-Jamuna junction down into the Sundarbans. And what I'll show you today very quickly is some data from these surveys. And then what I'll try and do after that is just look at some of this modelling work that we've been looking at in the Amazon. Our assumption at first was that as you go from upstream to downstream, because you've got this bifurcation of water, distribution of water and sediment, that these scours basically will be getting smaller as we move towards the coastal fringe. Right at the beginning, I'll say that was a wrong assumption, and that's not what is present at all. Techniques quickly, what we've done here from a series of vessels is use both limited multi-beam echo sounder surveys and also just single beam echo sounder and seismic chirp profiling. I'm not going to show you any of that today. What we've been doing is using all of these techniques to essentially measure the morphology, the shape of the channel beds at a range of sites across this transition. And what we've done is to work at a number of sites along the transition. I say, well, I'll show you the ones I'll show you just very quickly. The maps of today are the maps from these 6 different sites across the transition. And what I'm going to do is just show you something about their depth and their shape, and say a little bit about the change as we go across this proximal to distal transition. So if we start up near the right at the junction of the Jamuna and the Ganges. And we're not the first to survey here. There have been a range of surveys over the years. We've got a deep central scour between the two channels. The depth of the scour here is somewhere around 3 meters. Over time, looks like it gets down to 8 or 9 meters, up to about 20 meters. That's the depth of the scour, essentially the depth of the deepest point from the channel bed moving in. So you can see this central scour here, orientated between the two channels, stretches on for 4 or 5 kilometers. If we move downstream to Chandpur, just at the junction of the Meghna and the Padma, complicated here by the here at Chandpur, but a very deep scour hole around the hard point. Depths here, blue is about minus 50 meters, up to 0. So the scour here, from this point down to the deepest point of the scour, probably between 25 and 30 meters deep, concentrated and focused around the tip of the hard point. We move down in towards the delta and across to a site near Charkali. This is a scour at, I'm sorry, what I should point out as well in both of these previous sites is we've got abundant sediment, abundant sand moving through these scours, both of these scours, as sand dunes. So the beds of these scours are distinctly mobile, a lot of mobile sediment. As we move downstream, and this site at Charkali, what we can begin to see is we're getting scours here at the outside of the bend, but we can see with this scour here, we're beginning to get incision down into cohesive substrates. So you can begin to see here some slopes. There's a section across this scour, long profile across this scour here, where we're beginning to see very steep vertical slopes. And what it's telling us is that although there's mobile sediment, this scour is cutting down into cohesive muds as we go further downstream. Two sites here further downstream still. This one a bend scour, and again what you can see is depth of scour here, somewhere around 20 meters at the outside of the bend. Still mobile sediment here, but the whole of this bed is really beginning to be dominated by finer grain material. And if we move a little bit further downstream to a junction with the Shibsha channel, we can see a very distinct scour here down to about minus 45, 46 meters. And if we take a section across that scour, just across here, we can see this very steep face here, nearly vertical. And so again, what we're doing here is cutting down into cohesive substrates. There is sediment moving through here, but a majority of the bed here is dominated by muds and fine-grained sediment. And lastly, it's a very quick tour, I know, but lastly, a survey that was done by Steve Goodbreed a number of years ago, actually down at a bend right here down near the coastal fringe. And wrong way. If we look at this, what he's finding here is a scour hole over 50 meters deep, again cut into really quite a cohesive, strong, erodible muds, but giving us this very steep wall on the inside of the bend. So if we put all this together, essentially if I look at scour depth versus distance from the Jamuna-Ganges confluence, so I've got scour depth in red here, absolute scour depth from the bed to the deepest point of the scour. And what I've done here is just divide scour depth by the average of the flow depths of the two channels, or the one channel coming into the scour. What we can see is that essentially scour depth doesn't decrease at all to the fringe. It increases or stays stable. And in terms of relative scour depth compared to flow depth, again, it shows no sign of decreasing, and in fact potentially increases as we go towards the coastal fringe for sites that are located at both confluences, constrictions and bends. And if I look at mobility of these scours, and here's just a couple time lapse from Google Earth. If we look up at the Jamuna-Ganges junction over a period of 20, 30 years, as you all know, this site itself is really mobile. And so the site of the junction itself has moved by 13, 14 kilometers over the last 30 or 40 years. I put this one in, of course, because as Jassim said, the sites of the barrage are within this region here and the offtake of the Gorai. If I look to the same time span down in the Sundarbans, of course, the stability here of these channels and all these sites of junctions, bends and constrictions is much more stable. And you can see here there's, over the same time period, you can really at this scale see no real change in any of these sites at all. Really stable channels associated with these much finer sediments. There is movement, there are cut-offs, but not nearly on the same scale. So the mobility of these channels is decreasing, although the number of sites where we have scours at bends, at junctions, at offtakes, of course, is much greater in the Sundarbans and towards the coastal fringe. So here's the summary of this. These scours are ubiquitous. They show range in depth. They don't decrease in size as we go downstream. Tidal forcing becomes important, as well as the mobility of the beds upstream. And again, this may be important in terms of thinking about where we build infrastructure and what the impacts of any upstream changes may be. If I could just quickly, for the last minute, just have a quick diversion to the Amazon. Now, I've been lucky to work across here in the last few years, and we've been working on a range of projects to doing with the potential impacts of damming on some of the upstream channels in the Amazon. And the relevance of this is that damming in the Amazon is widespread, in the upper Amazon is widespread, and there are many plans for building more dams here. So here's a map showing the range of planned and existing dams. Here's their size. And these dams tap between 20 and up to 80% of the sediment behind them. And what we've been doing is trying to use some morphodynamic models, some reduced complexity morphodynamic models, to look at the potential impact of these dams. And what I want to finish on is just showing you two simulations that show one of these rivers coming from the upper Amazon. So these are essentially scaled on field work that we've been doing there. It's reduced complexity modeling, but it's a process-based geomorphic model, bringing in sediment transport, erosion, bank strength parameters, vegetation. And what we're doing here is looking at the situation of modeling over hundreds to about 1,000 years of the evolution of the channel. And we can see this meandering channel migrating, cutting off, basically a good reflection of what's going on. If I run that same simulation again, and this is work led by Muriel Bruckner, who's at LSU, and Andrew Nicholas, who's at Exeter, so it's very much their work rather than mine. If we run this scenario again and we trap 80% of the sediment behind the dam, which is a not unreasonable amount, what we see in geomorphic time over a period of decades to hundreds of years is incision of the floodplain. This is what Matt Condolf at Berkeley calls the hungry water effect. But the long-term impact is incision of a secondary floodplain below that of the primary floodplain, which changes the connectivity, the interchange between the existing channel and the old floodplain greatly. So the geomorphic consequence of this damming over periods of hundreds of years is potentially this very great change in the geomorphology, the connection between the floodplain and the channel. And again, I think that's an interesting factor to take account when we think about building any infrastructure in terms of dams and barrages, and when we begin to think about the impacts potentially upon not only water flow, but sediment flux. So with that, thanks very much. I know I went a little bit over, but thank you for listening.
Thank you, Jim. A very nice presentation, and I will have some questions, and I'm sure audiences will have some questions as well. Professor Chaudhary, you can present next. Yeah, I think you can go to presentation mode. The bottom.
Okay. Can you hear me?
Yes.
Okay. Well, thanks very much, Dr. Hussain and Dr. Imran, for giving me this opportunity to make this presentation. When Jasim asked me, my understanding was that we were going to discuss mainly the barrage, but then it looks like it has become more general. So what I have done is put few slides together where it will give some information on various projects I have been involved with as a practicing engineer and then as a consultant. And then we have been lucky in having a few large research projects which Jasim and I have been doing together. So I will just share some information on that with you. So with that, what is a barrage? As you might see in this particular case, it is mainly a fall structure where you try to raise the water level so that you can have off the channels can draw water on laterally. So wherever you will have a canal taking off from the river, there will be a barrage. So these are mainly in India, Pakistan, and Egypt. That's where mostly during the British days these were built, and some have been built later on. On diversion, then these again are you make available water at point A, and then you want to take it to point B where it might be needed. And then, of course, rivers are a different situation for flooding, as well as what Jim has outlined, various issues. So this is a short slide, which Jasim has already shown, so I won't spend too much time. Actually, he is the source of this particular slide, where it's showing where Ganges barrage will be, and this is where Faraka barrage is. So you can see this distance over here. Whatever is done at this location, of course, it will affect this part of Bangladesh, but then it will affect operations of Faraka barrage as well. So this is where if both countries can join forces and do it together, it will be for benefit of both. But if each one start to do things different way, unfortunately, it will be detrimental to both. Although by controlling water at the upstream end, damage could be more as we go further downstreams, especially for this particular new structure you are thinking. So this is what Jasim mentioned, which although built, but has not been really as effective as one would like to see. So as when I was asked, so I said, well, I don't have all the information, so I'm going to use my, what would you call, basic, well-known thinking about engineers. So who is an engineer? An engineer develops complex formulas based on vague assumptions and data obtained from incomplete tests and experiments with instruments of problematic accuracy. Believe me, most of it is true. We as engineers never have all the information you want to have to build, design, or plan any project. So you have to use what you have, and that is the situation here. Well, another saying is that engineer will do for $1 what others do for $2. Well, it can be looked at two different ways. One is that engineers optimize things and try to utilize the resources as best as you can. But to a pessimist, it can also look like engineers are cheap. So you can select whichever definition you want. On the diversion, I thought Indus Basin would be a very nice example. So here, this was even before this was signed in 1960, there were all kinds of barrages on the rivers in Pakistan for irrigation purposes. And they were working fairly nicely till India started to control whatever, and all the rivers are coming through Indian controlled territory. So this particular project was financed by actually Australia, Canada, West Germany, New Zealand, United Kingdom, USA, and of course IRDC Bank. So what was done was 4 left rivers, Indus, Jhelum, Chenab, these were given that Pakistan will have all the water for this, and 3 rivers, which is on the right side, which will be Satluj, Beas, and Ravi. India can do whatever they want to. So to accomplish this particular project, the objectives of this project, you had to build 2 reservoirs. One is Mangla, and other one is Tarbela. So both have really high dam, not like the barrage you are thinking of in Bangladesh. And then link canals took that water from there to the next river, and then from that to the irrigation canal. So as a result, all the water what was needed, which have been used for irrigation from these 3 rivers, you could utilize from these others. So here is just to give you a kind of bird's eye view of these are the various link canals which have been built, and these are other large. So just to give you an idea here, this is kind of average size canal. About 10,000 cubic feet per second is the discharge capacity, which is on the average side. And personally, I have some, how would you say, good memories, because I spent my, how could I go back?
You can probably
Stop sharing. You see, I'm not used to Zoom, so.
So
Okay,
on
yeah.
I think you can go back, I guess, on the
at the bottom there is on the
Okay.
the left
At
side
the
there is a
at the
back
bottom
arrow.
left side, you can restart.
Cancelled. Okay. Yeah.
Bottom left side.
Nope.
Please escape, then come out, and then just like go to the slideshow again.
Escape is not working.
Do you see that that blue the Chiron like Lower Bari Doab channel at
Yes.
Red Baluki? So I think on the left side of that panel, like there should be a back arrow.
Yeah, okay. Here. Yeah. Doesn't.
Just left side to the volume. Volume, if you see, there is a bottom left beside the volume.
Oh,
Maybe stop sharing and go back in again.
yeah.
Problem.
Yes,
Nope. Okay, so maybe I go there.
Just cut this page, please. Then I think you should be able to go back. Just on the right top ribbon, cancel this. Like there is a cross. Yeah.
Pause, stop recording, captions.
Just remove this. Just cut on this. Like there is an X. Just click on that.
No, it's a reaction, disable.
So just close this window of this YouTube, like, the...
Yeah, just close this window.
On top, on the right, there is a crossbar just on top of it, just on top of it.
Go a little bit up.
No, it's...
Oh,
No, nothing here.
no, just go a little left, your cursor. Then there
Yeah.
is a cross sign, so just click it.
No, there is no cross sign. It says more.
Dr. Hossain, I think he cannot see the top bar because of his window setting something. So he might
okay.
have to close it from the bottom.
Or maybe like, that's
Yeah.
might be the case. Okay, yeah, that's just close it, please. Oh, no. Then,
No.
So maybe Dr. Choudhury, close the PowerPoint and launch it again.
Yeah, okay. I said stop video.
At the bottom, like, so in the message part, there is this PowerPoint symbol. So if you kindly click that one, just in the one, yeah. On the left, that's the PowerPoint symbol, the P. It's orange red. Yeah, please, can you click it again one more time?
It says play now, cancel.
Yeah.
Well, you cancel, it comes here. YouTube.
If you go to the PowerPoint and there, click on that symbol, there were two screens. I think click on the left one. So go to PowerPoint. Go, yeah, and then click on the left one, and there it is. It.
Okay, here it is. I still
Thanks,
want
Jim. You just need to put it in the slideshow mode.
Yes, slideshow. There you go.
No.
Strange.
Okay, it's back, I think. Yeah, this is it.
Thanks.
Okay, thank you. Okay, so this one. In case you are looking for some information, this is a very good document which was produced long ago. In 1943 was the original irrigation practice. And Pakistan, actually 4 years ago, they have tried to update it. I was consultant to World Bank to provide them some assistance when they were doing. I think it should be finalized by now. So if you guys are interested, that has a chapter on barrages, and that should be helpful. Okay. This is a diversion. We actually in Canada, where I was working as an engineer, this was a very nice plan that divert water from Kootenay River to Mica River. Unfortunately, what happened? Politics got involved, and Columbia River is warmer as compared to Kootenai River, and question was, if you bring this water, which is 6 degrees cooler, all the beaches they have on various resorts on the Columbia River will be decimated. So as a result, this didn't go ahead. Okay. So other project I want to briefly discuss is this is Angostura in Costa Rica. Just to give you an idea that this kind of projects have been built where lots of sediment is coming in, and worry is that it will fill up because of dam, and as a result, all the objectives you have built the project for may not be realized. This one is a very critical one. Right near is Mount Arenal, which spews out very fine material almost every day, and then that get deposited in the valleys, and it rains fair amount in the area, and because of the mountain, all that fine sediment is carried into the river. And this particular dam would have filled, rather the reservoir, just in few years' time. So as a result, what was done, let's put some sluices there, and these are the 2 sluices which were designed by doing a model study. And this was done in early 90s, and project is working quite well. They have to sluice every year, and as a result, although there is lots of deposition and not much storage left, but the particular project is producing power as it would have as run of the river plant. So there are ways you can handle very difficult situations. Only question is how much it will cost and what would be the benefits. Okay, this is, I'm not going to go into video again to avoid the same thing happening. So this is a Warsic dam in Pakistan. It's a tributary of Indus River. This was built in late 50s, early 60s, and the reservoir filled up, and now every year they have to use the spillway to sluice, to take that or move that sediment downstream. As you can see, this water is a kind of really thick sludge which is going, and this they have to do almost every year. So as a result, they can utilize the project for power production. So these, I just mentioned that we had some research projects. This was modeling of flood hazards from dam failure and levee breach. Jassim was co-PI with me on this. It was approximately $3 million funded by NSF, and we had partners in Belgium, Portugal to start with, then later on we added New Zealand, Cairo, Egypt and Pakistan, and then there were a few universities in the US. So it was a 5-year project, but then with some extensions, we had for 8 years, lots of students graduated under this, and fair amount of work was done on modeling floods and etc. Presently, Jassim again is on this particular project as a co-PI. So here is use of biopolymer to strengthen urban infrastructure. This is, we are testing different biopolymers to see if you are overtopped, the levee, dike, or dam does not erode as quickly. So it involves both lab studies as well as numerical calculations. And here we have actually developed some algorithms to simulate levee erosion as it breaches. Then as compared to presently, you just have some rough rules of thumb you use. But this particular method allows putting various soil characteristics to compute how long will it take for the breach to increase. And that gives a better idea as compared to just picking some number out of air. There's another project ongoing. Again, Jassim is involved in this. It's funded by NOAA, and this is an institute set up in University of Alabama. So here we are modeling dam and levee breach and how to accurately come up with flood indentations. Okay, this is the last one. I'm going to try it. And then if it doesn't, then I think only one slide is left, which is summaries. This is interesting video where we did 1:50 scale model of closing breach in 17th Street Canal during Katrina. As you know, Corps of Engineers could not close it and whole city was flooded. Almost 2,000 people died. So here we will show that there are ways it could have been, but it wasn't. So here it is. So here we are lowering the different size bags. So you can see up to 30,000 pound bag is going to get washed away. And then we put a downstream barrier and 6,000 pound bag will close. See? Okay, so to summarize, personally, I feel Bangladesh has kind of challenging problems, but with the knowledge which has been developed over the years, there are ways which these can be handled, and it is much more economical as well as useful in having various adverse effects if this is done during design stages. So with that, I will stop and back to you, Jassim.
Thank you, Professor Chaudhry. Thank you, Jim. So I we can take some questions from the audience, and you can post them on chat, and then you can ask specific question to Jim or Hanif, and we can read them. Dr. Hussain, you want to read the questions if there is any? If not, then I'll ask some questions.
I'm yet to receive a question, but you can go ahead meanwhile.
Okay, so my question to Jim, you have seen that the proposed location of the barrage, if Bangladesh ever builds it, is very close to the junction. So is there a possibility that this huge scour might propagate towards the barrage and undermine this?
Yeah, I think part of that, Jassim, is going to depend upon what impact any barrage would have upon, especially bedload transport through the through to that lower part of the Ganges that's coming into the junction. So I think in potentially the impacts would be in more dominance of the Jamuna channel in causing a further shift of that scour potentially to the south. So I'm not sure about upstream movement. But it's interesting looking at the the movement of the Ganges over the last 30, 40 years, and looking at the movement of the scour. And again, I think the big question is how much that would impact sediment transport coming down through the. It's basically then changing that ratio in sediment yields between the Jamuna and the Ganges. So I think that would be the outcome. I would think would be a change in the location to the south of that scour. That's what I would imagine. I think
I don't know. Yeah, go ahead, please.
I was going to say, also, it's worth just stressing again that the scours there in those upper part of the system, essentially they're from what we see in those surveys, are cut into or eroded into completely mobile sediment. So again, in terms of any head cut erosion through something more cohesive, that at the moment it is not occurring there, and these are basically scours in completely mobile sediment.
Yeah, I'm not sure if they've done any study about the potential movement of the scour hole, but if Bangladesh considers going ahead with the barrage, probably there needs to be some more in-depth study about that scour hole, because it might undermine the whole thing.
Yeah, and yet the scour at the junction, of course, is located at the junction and downstream of the junction, and not, no influence further upstream. But I think again, it's just interesting looking at, say, the bar dynamics within the Ganges over the last 30, 40 years, and looking at the association between the bar dynamics, the growth of the bars, and actually what the associated bank erosion is around those bars. So I haven't done any work on those, but I would also think that actually looking at that downstream reach between the barrage and the junction, and looking at what the bar dynamics has been over the last 30 or 40 years would also be instructive to maybe guide what may or may not happen to changes in bar movement as you basically reduce the sediment flux.
Dr. Hussain, there is a question from...
Yes, there are a couple of questions. Just one comment to Azam. I think you can keep posting your questions. Even though you leave, we are going to have the responses, and it will be in the recording section. Okay. So our first question came from Muhammad Nazmul Islam. I believe that he joined us from Bangladesh. So in a downstream country like Bangladesh, what is the most suitable and sustainable solution apart from dredging to clear the riverbed and make it navigable? Yeah,
a great question, and one that I don't have an easy answer for. Is I think yes, as you say, in terms of the huge sediment load that is coming down, dredging seems, you say, apart from dredging, but for me, and again maybe Jassim and Hanif can comment on this, it seems that dredging in many locations would be the only option.
Yeah, then the issue becomes where you store the sediment. You need a storage space because there's a huge amount of sediment, especially in those large rivers. So even if you could dredge, where would you store them? And maybe by next year, they come back to the river.
Actually, what have been experienced is that although worries have been that sediment will be deposited upstream of the dam, but after these various ways of passing through the dam, through sluices, spillways, or whatever, presently the situation which is more detrimental is what happens downstream. So you have to come up with some kind of management processes on as this sediment is passed through the dam through some way, how it will get deposited. And I think by designing the downstream reaches of the river, making some modifications, you should be able to use the natural river itself to carry it to all the way. So as long as it is planned, start with, maybe you can avoid having immediate effect rather than let's go and build it and then see what happens.
I suppose just to add to that, the question is what's, as Jassim said, what's controlling the sediment flux coming in? So again, what are the potential impacts of a barrage or damming on that? And then what are the other sources that are going to change sediment supply, not over a few years, but over many decades? And I suppose when you begin to think about that, it's also what other sand abstraction and processes there are in the rivers, and also what projected changes there are in terms of changing flow as climate changes as well. So I think in terms of a long-term strategy, we've also got to think about what that changing sediment flux is due to changing water flow coming in from upstream constraints, whether it be from diversion or whether it be from changing discharges due to a warming climate. And those effects are going to be felt disproportionately in different parts of the Jamuna and the Ganges basins.
Okay, Simran, can I go and pose the next questions?
Yeah, sure. Yeah, go ahead.
Okay, so there are 5 questions. So I'll go through one by one. The first question came on scouring. Is there any historical changes of scouring in the locations you investigated over the years to show the flow has decreased and more sediments have been deposited over the years? I think this is for Professor Best.
Yeah, thank you. Again, interesting question. Yes, no, and one problem we have is just actually the number of repeat surveys at these sites that we've had. So in terms of surveys at the Jamuna Ganges junction, yes, there are repeat surveys there have been done by the BWDB over many years that have showed that the depth of scour changes between 8 meters and up to about 22 meters there. And that scour hole, as those maps or that animation shows you, has migrated up to about 11 or 12 kilometers over a period of 30 to 40 years. So the Jamuna Ganges junction site is moderately well known. The other site that I know that there are other surveys that have been done is down at Chandpur. And I know so that when we were there, the depth of the scour was around 25 to 30 meters. I know some earlier surveys when the channel configuration was different there, when the Padma was actually flowing further to the north. I think the scour there was nearly twice that at over 50 meters. At Chandpur, the situation is of course complicated by the impact of the hard point there, but certainly at Chandpur there is evidence that that scour hole has been much deeper in the past, which of course has got implications for the stability of the hard point and the design of the hard point. But at the sites that we've monitored, those are the only 2 that I know that there are repeat surveys. I presume also at Marwa there has probably been repeat surveys just because of the works there for the bridge.
Okay, Professor Imran, shall I move to the next question?
Sure.
Okay, so it's the next question, barrage. There is a discussion of Padma barrage in Bangladesh, side downstream of Farakka Dam. If I understood correctly, what is the benefit of this at all if the total control of water flow will be controlled by Farakka Dam?
Maybe Professor Chaudhry, you could.
Well, of course, if they control completely, then barrage becomes a kind of useless structure. So this is where it has to be done. And strictly speaking, there are international laws where riparian rights have to be not affected by any means. Upstream countries cannot do whatever they want to do, and same is at the local level. Like in your own home, you cannot do anything where you have a natural drainage, for example. Then the riparian rights have to be protected. So in this particular case, I think it is between India and Bangladesh to come to some kind of understanding. Only unfortunate part is that, as far as I can see, what Pakistan has experienced, even though treaty is there, like 2 years ago, they have been building all kinds of projects in Kashmir to divert the rivers. So it becomes ultimately world politics, how this thing is done, who is strong, who is weaker. But best is if both countries can come to some kind of understanding and then help each other.
Okay, Simran, can I go to the next questions?
Please.
Okay. So first there is a comment and then there is the question. And I think I'm going to ask these questions in two parts. There is a criticism of dam and barrage worsening flooding situation. Example, hydroelectric power dam in the hill tracts region of Bangladesh. Now, there is a movement in Bangladesh to keep delta as delta. Do you think engineering dams, barrages are worsening the situation in Bangladesh? So that's the part A of the question. The part B is, what are the actions taken by Bangladesh to address dam-based water diversion of India?
So it's for me, right?
Professor Imran, you are moderating.
Yeah, Professor Chaudhary, if I could step in. Yeah, I think you probably know about the experience of Pakistan. So obviously, relationship between India and Pakistan has been adversarial for a very long time, but this treaty have held up for a long time. And how was that possible? And if Bangladesh could come, would Bangladesh be able to do some kind of treaty? Would others need to step in, other countries? And yeah, how Bangladesh can ensure its water rights. At least Pakistan has been successful to some extent until now.
Well, excuse me, Pakistan has, but excuse me, not to the exactly what was specified in the treaty, because here and there have been all kinds of digressions. You see excuse me, the difficulty here is if one country is too strong, then they more or less end up doing whatever they want to do. But if there are, in the longer run, it affects both countries. Let me give you an example of Canada and US. They have treaty on Columbia River. And that has been followed to the dot. And it has helped both countries. US provided funding to build dams in Canada. Canada used those dams to produce power, as well as control flooding in Canadian part of the river, and as well as it enters the US. So if either of those two countries do not follow what was agreed to, yes, it will be detrimental. And in this case, if it is designed properly, then Bangladesh will have some, how would you say, control by saying, okay, you don't give us during winter, but that during summer we will flood you out. And you design the dikes in your part where you are protected. So those are the kind of tit for tat. It doesn't help anybody in the longer run, but it's always a good idea to have some way to have where you can say, well, if I'm not being pushed around completely, what are the various things I can do? So having other countries it helps for sure. And in this particular case, I think it's a large investment, which Bangladesh on its own would be almost impossible to come up with capital to build a $4 billion project. So other countries have to be involved, and this is where Bangladesh has to come up with what needs to be done and how they will do it to take care of various adverse effects. And I'm pretty sure if it goes ahead, there will be all kinds of negatives coming. Look what Aswan Dam has done in Egypt. Yes, there are adverse impacts, but at the same time, look at how much that particular project has added to Egyptian economy as well as well-being of the entire population. So it has to be kind of looked at not in a short-term basis, but on the long-term basis. So personally, I think it shouldn't be just quickly say, yeah, there will be lots of sediment coming in, which is not going to be controlled. It's going to fill up in 2 years, 5 years, 10 years. Like, I hope you don't do the same mistake Pakistan did. In Tarbela, there is no facility for releasing the sediment. So there have been all kinds of studies saying when it will get filled up and then what Pakistan will do. So as far as water storage is concerned, they will not, but still they will have that power they are producing. It's a almost 600-foot high dam. So as a result, it's a significant part of power which is produced. In case of Bangladesh, it's a small amount, but still 100 to 200 megawatt is lots of power in a developing country. So if once it's built, it's going to be in all perpetuity. You will be producing that power with very little what you call expenses going in, which will be the case for thermal. You have to burn either natural gas or oil or nuclear. Then you have to look for who is going to give you all the fuel which you can utilize to produce. So in this particular case, any water resource project, any dam project is very intensive for capital when it is built. But once it's built, service expenses are very minimal as compared to any other source of energy. So if you can use this, not power is a kind of, I was teasing Jasim that it is just like a bonus. Don't consider that you're building the barrage for power, but that is just coming as a bonus. You are using the water during winter for irrigation in areas where you need it. And if you can take care of the salinity problem, that will be a major plus for all that population which is in that area. I mean, their livelihood, again, going back to example of Pakistan, they had major salinity problem, although in the reverse direction. In Bangladesh, salinity is that you don't have enough what you call water table has gone down, so you are having a saline effect coming in, just like in South Carolina we have near the beaches. If they start pumping too much water out, then salinity start to come in. While in Pakistan, it was a reverse problem. They irrigated too much, and as a result, water table kept coming up, and then there was water logging. And as it comes to the surface, it brings up salt, and they were losing, I mean, thousands of acres every year. So that was a major problem as far as irrigation part was concerned. So they had to build actually lots of tube wells where they are pumping that water to keep the water table down, while in your case it will be other way around. So again, these are the issues which one has to gather the information, analyze it, and then take a decision. And that decision, most of the time, as you will find in engineering, you have to modify as you gather more information. Does that answer the question?
Yeah, thank you. I think it's a very insightful response to the question. Do we have any more questions to present?
I do not have any other question from my side. Yeah.
I'm just going to add to that, if I could, is I think also,
Yes.
you know, the long time scale is essential actually, and I probably have some different views. I think it's Hani on maybe the benefits and drawbacks of the barrages, but I think actually looking to see what the long-term impacts are on a scale of decades and plus decades, and looking to see what are the impacts actually when you take account of some of those other stressors that can affect the system. So when we look at salinity intrusion, yeah, it's certainly, you know, to doing with actually the change from discharge from water upstream, but then we've got to think about what's happening to substance, we've got to have what's happening to sea level itself, what's happening to other factors that are affecting sediment movement downstream. So I think the ability to actually look over a longer time period and begin to look actually what the effect is over a period of many decades to hundreds of years is essential when we're doing this, because we don't want to be in the situation 40 or 50 years down the line that we built another barrage and we're having the same effect but in a different part of the delta. And so that would be my concern, looking back to what some people have proposed for the effects of the Faraka barrage, is actually, are you transferring some of those problems elsewhere in 10 or 20 years time? So, you know, that would be my big reservation.
Yeah, I fully agree. You have to analyze these things not just for 5 years, 10 years. You have to consider it for the longer term, and then design remedial measures, assuming all you are assuming will be happening, but then you modify as you proceed. Most of the time, you end up modifying your operational procedures so that it does not affect as much as you thought it would.
Omar has a question. Omar is a professor from University of West Virginia.
Yeah, my question is more kind of general. I mean, keeping delta as delta, that would be ideal. Okay. However, that does not help us, you know, mitigate flood or do the irrigation necessary. So is there any way out, you see, without building those harmful structures? It's for, I mean, anybody can answer in the panel.
Okay, well, I will answer. I mean, you can see right from your question how it ended, harmful structures. So you have already made up your mind that this is a harmful structure. So what you need to do is be open-minded. Yes, whenever you do anything in nature, it's going to have some effect, some positive, some negative. The question for planners and designers is to take as much action as possible during the planning and design stage, rather than build it and then say, now what I do. Yeah. So I agree with you that whenever you do anything in nature, you are going to affect the basic what has been there. I mean, look in US, some of the dams which they built in Columbia tributaries, they are going back and blowing them up. Well, why? Well, we want to set it, but now they are not going to go back to the original shape they were. But again, what will happen if they continue? You say, well, you all these on the, just to give you an example of the Columbia River, if you blow up all the dams, all that power which is being produced, where it is going to come from? Whole area would be kind of in bad shape. So these things you can't just make up the decision based on without detailed studies, detailed investigations. And always you have to keep your kind of options where you're looking it more objectively, not try to tip the scale. Well, I want to build the dam, so let us come up with various assumptions. No, put in the information as is and let the chips fall where they will do. And then make the decision, is it good, is it bad, or what? It's a major investment. It's not only you are going to be messing around with nature, which has been there for a long time. But again, if we don't utilize all the developments which have happened, I always use this analogy that we will be still living in caves and hunting with bow and arrows. Why to use a gun? Bow and arrow did a pretty good job, right?
That's right.
No.
Yeah, Dr. Chaudhary, thank you. And this question is also directed to Jim, because I am a civil engineer myself with specialty in water. So I'm with Dr. Hanif Chaudhary, but take it as a sarcastic question. That is there any ecological way to live where we live? Keeping the environment as it is.
Yeah, no, I think, I mean, it's the fundamental question we ask all the time. I think Hanif, I agree with Hanif in a way that I think what we luckily are able to do now is to look at a range of alternatives. So yeah, I think it's a case of minimizing the amount of environmental damage that some of these structures may cause, taking benefits they bring. But I think, there are some, so if I look at the Amazon, there's fascinating work recently looking at actually the possibility of hydrokinetic turbines in the Amazon and comparing the amount of energy that you generate potentially from that compared to large scale hydropower construction. So I know there are lots of issues to there, alternatives now in actually how we begin to plan for things like providing energy. So there are other alternatives that may actually, in some places, not particularly in Bangladesh, give other ways of coping with this. There are things, that lots of people point to in terms of actually the efficiency of how we use our resources, which, you come down to the bottom line is that we often do a very poor job in the efficiency of how we use electricity that we generate. So I'm not, saying that to say that, that all of these things, obviously can't be built, because, that you're right. We need to do that as a society to improve people's living standards, to meet a whole range of things from UN SDGs, etc., etc. But we've got alternatives now where we can begin to look and see in different places, is this the best way? Not only in the design of structures that we may build, but are there alternatives that actually may give us another way of supplementing this in the number of dams we build, where we build them, how we build them. And undoubtedly the design of barrage and dams has improved markedly over the last 30-40 years, which means some of those issues can be ameliorated. You can't remove them, but maybe you can ameliorate them, and you can ameliorate them through the operation. That means that you minimize more the effects that you have on the downstream environment. So that, I mean, it's a sort of a gross statement to say, but I would think the positive thing is that there are alternatives in many situations that we can look at to supplement some of these things that we think about as more traditional ways of providing resource.
So you are a fluvial geomorphologist, as I understand. So what is your I think ecological kind of way of mitigating floods? I mean, energy, I understand. So, I mean, I'm not trying to be forceful here, because I also do ecology. So I understand that ecology has to be, intact.
Yeah.
But for flood, in the ecological way of flood mitigation is, you may build wetland, and then you may create buffers in terms of plantation, forestation in the riparian zone to slow down the water. But that does not do it all. So I would like to hear your perspective in this case.
Yeah, no, I think you're absolutely right, and of course, it's very context specific in terms of the river and the society that's around there that is looking for resilience. So I think you're right. You look at a whole range of things within Europe, for instance, with giving more room for the river, buffer zones, increased wetlands. Yeah, that won't work in lots of other situations. So I think one thing always impressive in Bangladesh and Cambodia is the resilience of people through traditional indigenous ways of actually coping with floods. So I think we have a lot to learn in terms of our infrastructure and how infrastructure is built about improving resilience. So I think again, it's not an easy answer, but I think actually some of that resilience being built in through the design of infrastructure that we have on floodplains, we can learn a lot and improve on that. Yeah, and then you've got a whole range of harder solutions in terms of what you do in terms of diversion of water or physical infrastructure. And in some cases, of course, there's no way around the fact that you have to have that infrastructure built. So, I'm certainly not saying, one size doesn't fit all. And I'm certainly not saying that you don't need those sort of hard engineering structures. But I think what we need to, what people do is to look at case specific scenarios and look at what range of alternatives there may be. So I don't know if that's an answer, but I think there's lots of positives, resilience design, as well as a way of flood proofing, as well as actually stopping the movement of water.
Yeah, I agree, and we are in the same page.
Yeah. Okay. Great. And it's always good to talk about these questions, actually, because sometimes people just don't ask those. So that's good. Good to know, Maya.
You just have to keep your mind open to both positives and negatives and analyze it and then go from there, rather than right at the beginning say, well, this is good, this is bad, and you are already starting in a kind of wrong way.
That's right.
Okay. You don't have any other question, Professor Imran? Should we wrap up?
Yeah, I think we're about 1.5 hours, so probably it's time to wrap it up. And thank you to the panelists and the audience for joining this very animated discussion. And we will probably have more of these sessions in the near future. So my take on this is that actually Bangladesh has very little option in terms of managing its waters, because all the water is coming from sources that are outside of this country. So yeah, building barrages, we already have one, but we are not being able to use that. And if we build another one and water doesn't come, then the barrage doesn't do its job. So whatever we do, we have to probably come up with some kind of solution, either regional or multinational. Building dam, probably only place dam could be built on Ganges would be in Nepal, and they already probably built some dams. So yes, I mean, those policies sometimes are driven by national politics more than the holistic approach. For example, Farakka is not doing what it was expected to do. Calcutta port is still silted, they cannot use it. And also Bihar is experiencing flooding because of backwater effect of this dam or of this barrage. So there is also movement in India to remove Farakka barrage. It's getting stronger with time if you look at the literature and news stories. So I hope those countries who are neighbors, they can try to understand each other and develop solutions that are equitable and meets everyone's interest, and at the same time not destroy those environmental systems that took hundreds of thousands of years to develop or built by nature. So thank you again. I think we can wrap it up. Thank you, Dr. Hussain, for organizing this.
Thank you.
Thank you, everyone.
Thank you very much for inviting me. I'd be very interested in joining in the future. It's been a great way to start a Saturday morning. Thank you.
Thank you, Jim.
Thank you so much.
Thanks very much.
Yeah.
Have a good rest of the day.
Bye.
Bye-bye.
Bye.